let's come back and do the next variety of numerical that's based on your molarity. And let's read the question. Fine. So what did they give us? If the density of methanol is 0.793 kilogram per liter, what is its volume needed for making 2.5 liters of its 0.25 molar solution? Okay, so basically when such numerical is given to you, right, you should have a clarity of what data is given to you, where to substitute, what to calculate. So first of all, in this particular thing, let us write the given data. So in the first thing, given data is, when you write what is given to you, you'll have a clarity. So they've given us density of methanol. So density is equal to 0.793 kilogram per liter. That's over. So how can I convert this into gram per liter? So 0.793 into 10 raised power of 3 gram per liter. This is over. Fine. So next one, we have two things, isn't it? If the here, what is the volume to be needed? One volume is needed. They're asking for the different volume, right? So there are two things. First, we have one formula, isn't it? M1 V1 is equal to M2 V2. We're going to apply this whole information in that formula, right? So first of all, what are there when I have to write M1? Let us divide this into M1. This is V1 here. Let us write here M2 and V2. Fine. So what is M1 here given to us? Fine. So do we have M1? We need to find M1, because what is the volume needed to find for 0.25 molar solution? There are two things given here. Fine. So M1 and M2. Fine. So here M1 I need to find out. How much is M2? 0.25, fine, 25 molar. Here in this case, volume also I need to find. Volume also not there. What is the volume here given? V2, they've given us 2.5 liters. So 2.5 liters, isn't it? Fine, this is over. Because we are going to divide it into solute and solvent, isn't it? Fine, this is how we are going to do. Now for calculating the molarity, first molarity is equal to, you're going to write weight by, okay, this one directly also you can write, isn't it? Yes. Okay, let's see how can I write this. So your density is given, weight by molecular weight, but density is given. So how can I write this? I can write density is equal to density divided by mass. I can write this, isn't it? Yes, density is equal to mass by volume, but here this is molarity, this is mass. Fine. How much is this coming up to? This is coming density 0.793 into 10 raised power of 3 gram per liter. Right, how much is the mass given? Right, so how much is this weight? I need to calculate the molar mass. What is that molar mass of methanol? Methanol is CH3OH. Now calculate for carbon. How much is that? For carbon, okay, 1, there's only 1 into 12 plus 3 into, okay, 1 into 12 methanol, this is okay, yes, 3 into 1.00 your 7 plus 16. When I do this, I get methanol weight is 32 grams. 32 gram per mole I've got. Okay, now substitute 32 gram per mole. Fine. So when you divide, you get molarity equal to 24.781 mole per liter. Okay, this is over. Now what did I get in this? Here I have got M1 I've got. Now substitute this M1 here in this case. Yes, so how much is M1? M1 is equal to 24.781. Okay, now you can do, isn't it? Yes, let us turn the page and do the sum. So what is M1 now? We have got two things, but let us write this formula 2. M1 V1 is equal to M2 V2. Now how much is M1? 24.781. V1 I need to find. M2 is 0.25. How much is V2? So take this V1 out. This goes the other way. 0.25 into 2.5 divided by 24.781. So V1 finally I've got an answer of 0.025 liters, because the volume is in liters. So this comes to 25.22 milliliters if I have to convert. Fine, this is how you are going to do the sum. See what data is given to you, see how to find out from the given mass or given information, and then finally take the final answer. This is how you're going to finally calculate, because they've asked us to calculate V1. Fine, let us come back and do the next sum in this. So in the next sum, they've given us a sample of drinking water was found to be severely contaminated. Okay, right, with what? It was contaminated with chloroform essence. Fine. So and it's supposed to be carcinogenic in nature. The level of contamination was 15 ppm by mass. Express this in percent by mass, as well as determine the molarity of chloroform in water sample. Both the things they've asked me to do. Fine. So when such numerical is given to you, as I said, every time when such numerical is given to you, try to write the given data. When you write the given data, you'll have an idea, okay, what is given, what should I calculate. This is how you're going to do the sum, isn't it? Fine. So here express it in mass percentage, as well as determine the molarity also. Both the things they've asked me. Fine. Let's start doing the numerical. First of all, what is given to us in a sample of drinking water, they said. Fine. So let's start noting the data. Right. So let us see the next question. Hope concepts are getting cleared gradually. See, you will not get the concept immediately. You need to keep practicing, then only you will understand. Fine. So next question. How many volumes of 10 molar HCl should be diluted with water to prepare 2 liters of 5 molar HCl? Fine. So here, in this question, what did they give us? Like how much volume? I need to find the volume, isn't it? Is how much volume they said. So simple. They've given 2 things. Let us note the data first. So according to this, the given data, the simplest numerical this is. Yes. So in dilution, like molarity, the dilution law. When what happens? What is the formula? M1V1 is equal to M2V2. So here, this is, let us take this as 10 molar HCl. Right, and the next one, okay, this is equal to, no, this quantity I'm going to take it as 5 molar HCl, right? So 10 molar, 10 into, I need to find V1 because how much volume they said, and this 5 into, what is the volume? 2 liters they've given, 2 liters. Fine. So V1 is equal to 5 into 2 divided by 10. Okay, this is liters. So how much do I get? I get 1.00 liters. This is how we would do. This is the simplest numerical. Rather, there's nothing much. Given data, substitute in the dilution law or the molarity dilution law, and finally get the answer. Fine. So let's see one more numerical based on molarity. Here, this particular question, molarity and number of moles, both the mole concept as well as molarity are related. Let's see this question. So here, calculate the number of moles and the amount in grams of sodium hydroxide in 250 centimeter cube of 0.100 molar sodium hydroxide solution. Okay, fine. So here, what should I do when I need to solve this numerical? How can I do this numerical? Let's see. So first of all, number of moles, both the things, calculate the number of moles I said. Fine. So let us start from here. This is your main thing. 0.100 molar solution sodium hydroxide. How much is contained? 0.100 molar sodium hydroxide solution contains, what does it contain? It contains 0.1 moles of NaOH in how much? In 1 liter. In 1 liter, 1 liter. Okay, or I can write this as 1000 centimeter cube of a solution. Yes, I can write in this way. Okay, fine. So number of moles, if I have to find number of moles of sodium hydroxide, fine, in 250 centimeter cube of solution. 250 centimeter cube of solution. How can I write this? I write this as molarity into volume of the solution. This is liters. So how much is molarity given? It is 0.1. How much is the volume? 250. You're standardizing it to 1 liter, right? So molarity is equal to 0.1 into 250 divided by 1000. This comes to 0.025 moles of sodium hydroxide. Okay, this is over. Right. What should I find? I need to find the this one also, isn't it? The total. Asked me to calculate the amount in grams also. There's also one more thing which I need to find. So when I have to calculate the amount in grams, so let's write first of all molar mass of sodium hydroxide molar mass of sodium hydroxide is equal to 40 gram per mole, right? Fine. So now mass of NaOH in 250 centimeter cube, because that is what I need to find, is equal to N of KOH into M of KOH. This is formula. So N of KOH is how much? 0.025 into M of KOH is what? 40. When I multiply, I get 1 gram. That's it. So both the questions, hope these are clear, both the concepts. Let's come back and do the last variety of molarity numerical, which is there. Fine. So here, let us see the question. 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of the solution. Calculate the molarity of KOH in the solution. Okay, yes. So here, what should I find? I need to calculate my molarity. Direct formula this is. Basically, how let us write? Molarity is equal to moles of solute. Moles of solute by volume of solution in liters. Volume of solution in liters. Isn't it? Yes. Done. So here, what data is given? Moles of solute means nothing but weight by molecular weight, isn't it? But here they've given 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of solution, they said, right? So first of all, let us calculate the molar mass and then come back. Molar mass of KOH. Molar mass of KOH is equal to how much? 56. Okay, gram per mole. Hope this is clear. 1939, 60 plus 16 plus 1. So this comes to 56. So let us 56 gram per mole. So here 2.8 grams. This is 2.8 grams of water. Okay. 2.8 grams of KOH. 2.8 grams of KOH is equal to now. Like how much weight, isn't it? This should be the other way. Molar mass of this contains 2.8 grams contains how much? Okay. So what do I get? 2.8 divided by 56 moles of KOH. Okay. How much do I get? I get 0.05 moles of KOH. Okay. Now I've come almost closer to the sum. Now let's come back and write. So molarity is equal to now. Molarity is equal to, again I'm writing the formula, moles of solute divided by your volume of solution. Volume of solution in liters. Yes. So how much is the moles we got? 0.05. Volume of the solution 200 by 1000, which comes to 0.25 moles per liter. This is your sum. So this is how you're going to calculate the molarity of the gas. So I've done the various combinations, almost 12 numericals regarding molarity. Let's come back with the next set, that is calculating your or doing the numericals based on limiting reagent.